In this lesson, you will learn to use the remainder and factor theorems to determine factors of polynomials. And this lesson is kind of like a side note to the previous lessons, where we have two different theorems that we're going to discuss, the remainder theorem and the factor theorem. The remainder theorem says that if you're dividing two polynomials, so in this case, a polynomial, 2x to the third minus 7x squared plus 5x minus 1, divided by the other polynomial, x minus 3. Now the remainder theorem only works if you're dividing by something that can be divided using synthetic division. So if you cannot use synthetic division, then you cannot use the remainder theorem at all. The remainder theorem, what it says is that if you're dividing by something like x minus 3, if I take the opposite of this, so the opposite of the minus 3, so a positive 3, and plug it in for x in the numerator, then whatever that's equal to will be the remainder when I divide. So if I put a positive 3 in for x, what I have is a 2 times 3 cubed minus 7 times 3 squared plus 5 times 3 minus 1. If you solve this, you're going to have 2 times 27, which is 54, minus 7 times 9, which is 63, plus 5 times 3, which is 15, minus 1. 54 minus 63 plus 15 minus 1 would equal 5. So this here, the 5, would be the remainder when I were to divide these two polynomials. So let's try one more. Here we have x to the third plus 4x squared minus 8x minus 6 over x minus 2. And to find the remainder, I take the opposite of this. So if it's negative 2, make it a positive 2, and plug it in for x. So instead of x to the third, we have 2 to the third. Instead of 4 times x squared, we have 4 times 2 squared. And instead of minus 8 times x, we have minus 8 times 2. So 2 to the third power is 8. So we have 8 plus, and then 4 times a 4 is 16, minus 16 minus 6. Well, 16 minus 6 is 0, 8 minus 6 is going to be 2. So the remainder is going to be 2. Now this remainder theorem is a quick way to find the remainder instead of dividing out every time. Because yes, I could use synthetic division and I could find the remainder, but there are times when it would take forever to do that. For example, if you had like x to the 1000th power, minus 1 over x plus 1, and you want to know the remainder, well, you'd have a 1 for that x to the 1000th power, but then you'd have all the placeholders to put in for the x to the 999th power, 998th power, and etc. You'd have like 900 something zeros that you have to put in there. And that's not going to be fun. But what we can do is we can use the remainder theorem to just plug in the opposite of this. So we have a negative 1, put that in for x, raise that to the 1000th power, minus 1, and we can see that negative 1 to the 1000th power is just 1. 1 minus 1 is going to be 0. So within like a few seconds you can find the remainder, as opposed to a very long time if you try to divide using synthetic division. And then what this is useful for is we can then determine if something is a factor or not, which leads us then to the factor theorem. What the factor theorem says is that if the remainder is 0, then what we divided by is a factor. So ignoring polynomials, ignoring algebra for a second, if you were just looking at numbers, so just basic mathematics, if you were to say, is 4 a factor of 8? So is 4 a factor of 8? Well, the answer would be yes. But the reason is because if I take 8 divided by 4, the answer is going to be 2 with no remainder. But if I said is 4 a factor of 9, well, if I take 9 divided by 4, there is a remainder, 2, and then a remainder of 1. So because there's a remainder, we can conclude that 4 is not a factor of 9, and because there is no remainder, we can conclude that 4 is a factor of 8. And that's the concept behind the factor theorem. where not only is that true for numbers, but also for any other expression. So let's say that you're asked to determine if x plus 1 is a factor of the polynomial of p of x equals x to the 12th minus 3x to the 8th minus 4x minus 2. So to determine if it's a factor or not, we would have to divide and see what the remainder is. Well, a quick way of doing that is by using the remainder theorem, where I can say, okay, we're dividing by x plus 1, so I take the opposite of the 1, make it a negative 1, plug that in for x. So instead of x to the 12th, we have negative 1 to the 12th. Instead of 3x to the 8th, we have 3 times negative 1 to the 8th. And instead of 4 times x, we have 4 times negative 1. We can solve this. Negative 1 to an even power, to the 12th power, would become a positive 1. Negative 1 to the 8th power is also a positive 1. So this becomes a positive 1. This is negative 3 times 1, or just negative 3. And then negative 4 times, or minus 4 times negative 1. 4 times negative 1 is a negative 4 right there. So then we have 1 minus 3 is negative 2. Negative 2 minus a negative 4 is a positive 2. 2 minus 2 is going to be 0. So this is the remainder. The remainder is 0. So therefore, x plus 1 divides evenly, and therefore, yes, x plus 1 is a factor.